First and second group are called as S block. Then these are which block? D block elements. Then from here you have P block. At the bottom, F block. In F block, these are 4F series. Which is even called as lanthanoids. And these are 5F series called as actinoids. And these are continuation of 6th and 7th period. Hydrogen, below hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Here, beryllium, radium. Then in D block you have candium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper and gold. Here you have helium, boron, carbon, nitrogen, oxygen, fluorine and neon, argon, krypton, xenon, astatine, xenon, after xenon, radon, and what is this? OG, organosine. Some of the elements are filled there. Here, after boron, aluminium, silicon, phosphorus, sulfur, chlorine. Then what we have here? Gallium, germanium, then arsenic, correct? Some of those elements. Then selenium, bromine. So that is an outline for periodic table. We'll have the description of this. Along with that, you need to understand the way of numbering these groups in Roman number system. Groups are numbered in Roman number system. This will be 1A, 1B, 2A. Where is 3A? Which is 3A? 3A is 13th group. Here it follows. 3A, 4A, 5A, 6A, 7A, and 8A. B starts from here. 1B, 2B, then 3B, 4B, 5B, 6B, 7B, and 8 to 10. These together are called as group number 8. That is iron, cobalt, and nickel family are called as group number 8. Okay. Let us discuss the brief of this periodic table. Hence, here the elements are classified into groups and periods. What are periods? Or how many periods are there? 7 periods. Hence, periodic table has 7 periods and 18 groups. Then what else? to say about the name of this period. First period is called as period number. First one is called as shortest period, which contains how many elements? Only 2 elements, hydrogen and helium. Second and third contain same number of elements. Second and third are called as short period. How many elements it has? 8 each. Same as that, 4 and 5 are called as long period. They have 10 elements plus 8 plus 10, 18 elements each. Long period with 18 elements each. Then 6th and 7th are very long or longest period. They have how many? 14 elements from F block is added up, making 32 elements. Right? F block to 18, 14 elements are added. That becomes total of 32 elements. Before, the 7th period was called as incomplete period because earlier there were some space to fill that that series. It was not completed, but now it is already complete. Hence, it is also belongs to longest period. Correct? Any doubt till here? So we'll erase this and move to the next discussion. We'll see some of the points regarding the blocks, different blocks. S block. The periodic table is classified into 4 blocks. Classified into 4 blocks. The first block is S block. Tell some of the specialities of this S block. Can say about the configuration. What is the outer shell configuration? NS1 to NS2. NS1 makes the first group element, NS2 is the second group element. Then what else you understand from the S block? What else? Spandana, can you tell some speciality of S block elements?
They are called as alkaline metals.
Not all. First group elements are called as alkali metals.
Second group element is alkaline earth metals.
Very good. First group are called as alkali metals. Second group are called as alkaline earth metal. Then what else?
Their outermost electronic configuration is 1s1 and 1s2.
NS1 and NS2. Outer shell configuration is NS1 and NS2. Are these, which kind of elements these are? Metals. All of them are highly electropositive metals. Which type of compounds do they form? Is that ionic, coordination, covalent? Which type of compounds they form? Compound of these elements with non-metals has which property? Which property? Such as sodium is one of the elements from this group, right? With the chlorine, it forms sodium chloride. What is the property of that compound? Which type of bond they have? Ionic compound, right? These forms mainly ionic compounds. There are some exceptions, but most of them are ionic compounds. If they form their oxides, metal oxides, which nature it has? These metal oxides are basic in nature. They form basic metal oxides. Basic metal oxides. And to add something on this, The salt of these metals give characteristic colors to the flame test. You have heard this. Have you seen the flame test in the lab, inorganic analysis? You have not done the flame test in the inorganic analysis in the lab. You have done? No. The salts of barium, strontium, calcium. Spandana, have you done flame test?
Yes,
Spandana?
ma'am.
Yeah. So you have seen some of the salts giving different color to the flame test. Flame test is in fact, the salt is made into a paste with the concentrated HCl. In a watch glass, you will take the salt, put little concentrated HCl, make a paste out of it. Using a glass rod, you take that paste and hold it to the flame, Bunsen flame. And you will see different color given to the Bunsen flame. That is called as flame test. And the salt, whichever you have analyzed, all are from S block, such as, can you give some example? What is the color of salts of, it is not given by only the metal, it is from the salt of this metal. Salt of lithium, it can be lithium chloride. Which color it gives? Pale pink. Lithium gives pale pink color. Sodium, golden yellow. Potassium, lilac, or can say purple. Barium, apple green. Then strontium, crimson red. Calcium, brick red, etc. This is a characteristic property of the salts of these S block elements. These are the colors given to the flame during flame test by these elements. What is the valency of these elements? How do you find valency of these elements? What is meant by valency? Valency? Huh? It's not number of electrons in the shell. Valency is number of electrons involved in bonding, which is almost same as oxidation number, oxidation state. You know oxidation state. What is oxidation state? Sodium's oxidation state is +1. +1. What is the valency of sodium? 1. Remove that sign, number will be the valency. That is the difference between oxidation state and valency. Oxidation state is said along with the sign, valency is only number. Chloride has oxidation number -1, its valency is 1. This is oxidation state and this is valency. Okay. Is there any relation of valency of S block elements with the group number? Any relation of valency with the group number? Is there? What is the valency of sodium, potassium, rubidium, etc., starting from lithium? These all are +1 charge, no? +1. The other side, magnesium. How much? +2. These all have +2. These are from first group and these are from second group. So valency and group number, do they have any relation? Valency of these elements matches with their group number. Yeah, next point. Valency of S block elements matches with the group number. This is required where you'll get the question by giving atomic number or they mention the atom to write the position of the atom in the periodic table. Where if it is from S block, you can easily say its number of valence, that's a valency, it's not number of valence electron. Valency is equal to the group number. Is there any difference between valency and number of valence electrons? In S block, it is same. In S block, valency is same as number of valence electrons. but it is not same always. For s block elements, valency and number of valence electrons is same. Next, p block elements. P block elements, which is the position of p block in the periodic table. Group number 13 to 18. 13 to 18. There are total how many groups? 6 groups, which come under p block. Does it start from period number 1? P block? Is there any element in the period 1 belonging to p block? Which is it? My question, does the p block begins from period number 1? Which are the elements of period number 1? Which are the elements belonging to period number 1?
Hydrogen and helium.
Hydrogen and helium, no. Isn't it? Correct, Darshan. Now question is, does any element belong to period number 1, which is a p block? No. Which are the first period elements? Hydrogen and helium. Hydrogen belongs to which block? Hydrogen belongs to S block. Helium belongs to which block? Helium belongs to which block? P block.
P block.
No. Then what was my question? Is there an element of first period belongs to P block? Which is that? Helium, no. So you'll find P block element from starting from 1st to 7, all the period. And what is the speciality of helium? Do you know? Helium belongs to P block, but if you see the configuration of helium, what is the configuration with atomic number 2? 1s2. It doesn't have any electron in the p orbital. That is the speciality of helium. Helium belongs to p block, but doesn't have any electron in the p orbital. But still it is placed in the p block. Why it is placed in the p block? Because of its inert configuration. And it comes in the rare gas family. In spite of not having any p electrons, helium is placed in p block due to its inert behavior. Because inert gases come only in p block. Configuration, outer shell configuration, NS2, NP, 1 to 6, rare gas, followed by NS2, NP, 1 to 6. That's outer shell configuration. Type of compounds these elements form, nature of bond. Before that, which type of elements these are? Are these metal, non-metals? Most of them are non-metals and few are metalloids. P block has metals and non-metals. Most are metals, metals in bracket most, and even, sorry, not metals, non-metals have non-metals, that is most of them, and metalloids. Non-metals and metalloids. Hence, what type of bond they form? Covalent molecules. These form covalent compounds. These elements form covalent compounds. If they form the oxides, what is the nature of the oxides? As non-metals, non-metal forms acidic oxides. non-metal forms, acidic oxides. Now to talk about their valency. How to find valency? Here, is the valency and number of valence electrons same? Or what the relation valency has with the group number? Which we had in S block, very simple. Group number matches with valence, which is equal to valence, the valence electrons. In S block, valency and number of valence electrons was same. But here if you see, let us take the elements from 13, 14, 15, 16, 17th group. From the second period, these are group number, period number is 2. This is the element of period number 2, boron, carbon, nitrogen, oxygen, phosphor, fluorine. 18th group is neon, right? We'll write the number of valence electrons. Number of valence electron. How do you find number of valence electrons? Outer shell electrons. Boron's configuration is 1s2, 2s2, 2p1. This is 2p1. This is 2p2, 2p3, 2p4, 2p5, 2p6. Along with the 2s2. So 2s2 is common everywhere. 2s2. Right? So what is the number of valence electrons here? 1s2 is the inner shell. Second is the valence shell. Number of electrons here is called as number of valence electrons. 3, 4, 5, 6, 7 and 8, right? Whereas what is the valency of these elements? What is the valency of boron? How do you find valency? A simple way. You just find the compound of these elements with hydrogen. What is the compound of boron with hydrogen? BH3, right? BH3. With the carbon, CH4. With the nitrogen, NH3. With oxygen, water is there, H2O. Hydrogen fluoride. Rare gas doesn't form compound. Hence, number of hydrogen is the valency. What do you mean by valency? It is number of electrons used for the bond formation. Hence, number of hydrogen. Hydrogen has 1 electron. The element gives 1 electron. So, 3 hydrogen will share 3 electrons. So, here 3, here 4, here 3, here 2, here 1. This valency is same as number of H atoms in these compounds. Now you just observe, does the valency match with number of valence electrons here? Does it match? It matches up to carbon, right? Up to carbon. So for carbon, boron and carbon, number of valence electron is equal to valency. Later, what is the relation you are finding? Later it becomes 8 minus number of valence electrons, is it? Valency is at valence equal to 8 minus number of valence electrons. We just find valency equal to 8 minus valence electron, 5, that is 3. 8 minus 6 equal to 2. 8 minus 7 equal to 1. Here 0. 8 minus 8 equal to 0. This is for what? 15th group onwards. For 3rd and 4th, 13th and 14th group, valency and number of valence electrons are same. 15th group onwards, valency equal to 8 minus number of valence electrons. What's the rule? For group number 13 and 14, valency is equal to number of valence electrons. And this rule is for what? 15th onwards. Spandana, is this clear? Spandana, is this clear?
Yes, ma'am.
Yeah. I want another relation between the group number and number of valence electrons. Group number and number of valence electrons. How do you relate? Group number are here, number of valence electrons are here. How do you relate them? Isn't it 10 plus number of valence electrons? Is it? What are these valence electrons? Those are Ns plus Np electrons, right? Therefore, for p block elements, this is the generalized statement. This is useful when the question is asked to predict the group number when electronic configuration is given. If it belongs to p block, you will apply this formula. What about in s block? Group number and number of valence electrons are same. But for p block, group number is 10 plus number of valence electrons. Clear? These also you are going to include in the list of formulae in this chapter. Okay, what all you got? These rules from S block. Relation between valence electrons and group number, which is same in case of S block. But when it comes to P block, those are not same. There is variation. That is regarding the P block. We'll see some of the properties of D block elements. D block. Which are the groups falling under D block? Group number 3 to 12. There are 10 groups. Each 10 groups, each with how many elements? There are 10 groups, each with how many elements? 10 elements in a 4 period. That makes 40 elements. This is group number, these are period number. From where to where? It starts from 4, 5, 6 and 7. In 4 you will find 3D series, period number 4. These are period number I am writing. In the 4th period you have 3D series, 4D series in the 5th period, 5D series in the 6th period and 6D series in the 7th period. Hence there are 4 D series called as 3D, 4D, 5D, 6D in 4th, 5th, 6th and 7th period respectively. Each period contains 10 elements each. Therefore, in 4 periods you have total of 40 D block elements. These all are metals. All D block elements are metals. Hence, they are electropositive to some extent, but not as electropositive as S block elements. Their electropositivity is less than S block elements. To say about their properties, in P block we said they have some common valencies, but in D block elements they show variable valencies, variable oxidation state. Or what is the general configuration of these elements? D block, rare gas with NS2, NS sometimes 1, sometimes 2, or we can start from N minus 1, D 1 to 10, NS 1 to 2. It should be NS. Usually in NS orbital, how many electrons will be there? 2. Sometimes it becomes 1. where when it becomes 1, when d orbitals half filled or completely filled configuration has to be maintained. Otherwise, ns is always 2. Commonly, ns will have 2 electrons, but rarely it will get 1 electron in order to maintain the half filled or completely filled configuration of previous d orbital. Right? Now, how will you find the valence and valency relation here? Valence and valency relation we can't generalize because I said they show variable valencies. These elements properties, they show variable elements. List down the properties. Variable valency. Metals. Yeah. Then few more properties like color. You had D block element full chapter, right? There you learned some of the properties. Most of them form colored compounds. Yeah, write one by one. Most of them form colored compounds. Most are paramagnetic. What is paramagnetic? What are paramagnetic substances? Getting weakly attracted by the magnetic field. Weakly attracted by the magnetic field. Weakly attracted by the magnetic field. What else? What type of compounds they form? Yes, act as catalyst, right, good. Act as catalyst. Which type of compounds they form? Coordination compound, right. They form coordination compounds, interstitial compounds, etc. Coordination compounds, interstitial compounds, these all are formed by these elements. Now to find the group number, we'll take the element from 3rd, 4th, 5, 6, 7, 8, 9, 10, 11 and 12. Scandium, titanium, these elements. Its atomic number starts from 21. Scandium starts from 21, 22, 23, etc. When you write the configuration, this will be 3D1, 4s2, 3D2, 4s2, 3D3, 4s2. This is 3D5, 4s1. Right? Anomalous because of the configuration. This is 3D5, 4s2, 3D6, 4s2, 3D7, 4s2, 3D8, 4s2, 3D10, 4s1, 3D10, 4s2. Correct? Now, how to get the group number? I want the group number. These are group number. We have marked here. I want the relation between group number and valence electrons. This is 3 means 3D plus 4s. 3D plus 4s. These electrons are added, no? So this should be n minus 1 d electrons plus ns electrons together. Group number is obtained by n minus 1 d electron plus ns electrons. Clear? The remaining will continue in the next class.